Hi, welcome to the DataBasic podcast, where we bring you insights and knowledge to help you navigate the complex world of data science. In this episode, we are joined by Andrei Ilie, Data Science Engineering Manager at Bolt and Valedictorian of Master of Computer Science and Bachelor's at Oxford. Our goal is to cut through the hype of machine learning and AI and provide you with the information that matters to your development. Let's dive into the conversation about two different approaches of buying data for training algorithms and owning data to bring impact for the products.
So, hi, Andre. Welcome to the DataBasic, the World Data Science Society podcast. Alexandro and I are hosting it today, and we're very excited to have you.
Thank you for having me. It's a really exciting opportunity. And first of all, congrats for all the cool work you're doing as part of your society. I've been reading up a bit about your work. Alex was telling me a bit as well, and it's really impressive.
That's brilliant. Probably it's funny to see that you've done some research on us, not only us on you. So it's quite thrilling to see that you're eager for this episode as well. And thanks a lot for joining. That's really great for our audience because you've also studied in the UK, so we have a lot of common grounds here. We are coming from Warwick. We're pretty close by, actually. So Oxford is just 30 minutes ride by train. So yeah, I'm pretty excited about this episode, and I think that what I would like to start with is to emphasize on the power of connection, because I think whenever you find the common ground between you and another person that you want to approach, it will be much easier to get to know them better and to reach out, and that would start forming a connection and a bonding there. So yeah, I guess because we are all interested in data science, we've been also studying in the UK. We're still students here, but on the personal level, me and Andre, we are coming from Romania, so that's a bit more of a connection. So yeah, thanks for joining, and let's get to it then.
Let's get to it.
So, Andre, your journey is very inspiring, and I think there'll be a lot of takeaways for our students, especially with, everything that you've accomplished so far. You're doing a PhD, you've been a quantitative researcher, and now you're working in Bolt as part of data science. So, if you could tell us a little bit about your journey, how you progressed, how you got into the field of data science, and what interests you the most about this field.
Of course. I can go back to my high school days when I was actively taking part into maths competitions, computer science competitions. I used to be in Romania's national team for international mathematical Olympiads in the extended team. And along the years of high school, I was also thinking about transitioning more into computer science. Back then, the sort of people who were going to the maths Olympiads were also going to the computer science one. They seemed quite interchangeable very often, so it was sort of natural for me to try computer science as well. And when going closer to finishing my studies, I decided to apply to a computer science degree. I looked a bit into what different universities offer, and I noticed that the courses that Oxford was offering were very theoretical in nature, were very close to maths. So I wanted to learn more about computer science. I wanted to get some let's say hands-on experience, but at the same time, I really wanted to keep my let's say theoretical theoretical approach to things. I really loved maths generally. So I thought that Oxford would provide best of both worlds, and also like a nice transition from the very theoretical stuff towards something more practical in the end. So in Oxford, I studied for my joint bachelor and master's degree, where I ranked top of my class in both of them. And after that, I decided to come back to Romania. It was sort of my plan since I went studying there that I would want to go there, study, learn as much as I can, then be able to come back to Romania and work in a meaningful place, in a meaningful role. When I first came back to Romania, I first worked at the only hedge fund that was available in Bucharest back then, called WorldQuant, and also in parallel I started my PhD at the University of Bucharest. Unfortunately, the hedge fund where I was working closed after, I think, slightly below half a year, because they closed down the Bucharest branch. So I had to find like new opportunity. I was a bit in the wild because I didn't know too many other opportunities in Bucharest that would suit my interests. This was a sort of safe let's say not safe place. It was rather a bubble because I knew many people who came back from abroad to work at WorldQuant. So I was a bit in the wild, and then I started researching the local market. And what I found was that there are like so many cool opportunities, but out of all, Bolt was the one that really stood out because more than the others, it was also providing a proper product to work on and real life projects that would interact with millions, tens of millions of clients, and even potentially even above that. So since then, I joined Bolt. I was initially working as a data scientist, and I specialized in the ETA and routing domain. I was building the machine learning models that we use for our ride-hailing app. So many people might be very unhappy at me for their very bad ETAs, but this is something that we're continuously improving. And I think that I was the first data scientist dedicated, let's say, only to these areas, like only focusing on improving ETAs, making ETAs better. So I was working on that for a while, and slowly I've been picking up more topics. I've been building up the food preparation time models as well at Bolt, and then some, let's say, operational improvement models for the way we deploy or the way we pick up our scooters from the streets, because we also operate this scooter sharing business where we deploy scooters in town and they're being used by our clients. So I've been optimizing the way in which we deploy them, the way in which we pick them up to reduce the operational cost. So I got so while specializing in ETAs, I also got a bit to see this operational side, this let's say mathematical optimization side. And after 1 year, I became a team lead, hiring people to help me like with all of these topics because they were growing quite broad. And after a couple more months, I became an engineering manager for this group, which comprises of people working on maps problems generally, so not only ETAs but maps problems, food delivery problems, and scooter sharing, what we call rentals problems. And now we've grown quite a bit, and it's actually 3 proper teams in my domain. So now I'm an engineering manager for a group consisting of 3 data science teams working on these topics that I mentioned. And I think this is a fast walk through my, let's say, my education and career since the high school days.
Yeah, no, that's clearly amazing, and congrats on graduating top of the class at Oxford, and all of your achievements, especially those in high school in Romania, because I'm not sure if people are aware, but it's quite competitive to get at that level in Romania and in the mathematical and computer science Olympiads, because there are really brilliant people out there. So it's something that makes you stand out, and maybe we'll walk slowly through Oliver's journey and break those into smaller bullet points, and discuss various stuff. That it was pretty theoretical, your degree at Oxford on computer science, and you did a lot of mathematical things there. But how are you coping with those modules that you didn't really enjoy? Let's say maybe you had some system engineering or some, I don't know. I'm not sure exactly what modules you are taking there as part of your degree, but I'm guessing there are some low-level coding things that are going on that maybe they are not that impressive or interesting for you.
I think that essentially I tried to find some joy or entertainment in any subject, because that was the only thing to make some subjects that I wasn't like really keen into deepening, to make them enjoyable, to make them let's say to make them dealable with. Yeah, for example, in the first year we had the same, if I recall correctly, order of 8 subjects. I might be wrong. Let's say 8, 10, whatever, like that would be the order of subjects that we have for a year, and they're the same for everyone. This is called the preliminary examinations module, and this is the same for everybody. And after that, once you move in the second year and past, it gets way more optional. You're getting to choose your curriculum quite a lot. And I think there were only 4 more subjects that were mandatory, and these were rather about programming. These were about OOP, if I recall correctly, and a couple other things which are very, very common in computer science. I would say I can't recall exactly, but yeah, generally with that sort of freedom to choose everything else apart from this, I managed to create really nice. I would say that I created really nice sets of subjects that I enjoyed. And of course, there were like some parts that I didn't enjoy out of the ones that were mandatory, because maybe like my interest wasn't in the low-level digital systems where you'd learn a bit about how controllers work and about how the sort of lower-level hardware works in general. But still, after finishing them, I ended up having some sort of better understanding of how things work at a lower level. So I can't say that there was anything that I found particularly bad or anything that I wouldn't read right now, because I think that overall they help you get a well-rounded understanding of the computer science topic in general. And maybe this differs from uni to uni, but more from educational system to educational system, because then I know that in Romania there are very few optional things that you can pursue. Very often, once you have started some degree, you would stick to quite a few topics which are mandatory and have very few optionals, and that might be a bit more annoying indeed. Then of course you might want to just get rid of the topics you're not interested in if there are too many, and if they're there like for too long, like past the second or third year, it already gets annoying because you want to get more specialized, and such mandatory courses might not allow you to. But yeah, I think that's a particularity of each system. So for me, I can say I was lucky to not have too many such cases, and whenever I had, I still found something interesting in them, even if it was not what I was pursuing.
Yeah, no, I agree. Like, cause that's why I changed and came to the UK, because I know usually the first year has a lot of mandatory stuff, because they want to give you the backgrounds in order to further study different subjects and to get you on a common ground with most of the people. So yeah, the first year was like this for data science as well. There are good modules. There are quite good modules. We had, like, for example, for my course, we do some statistics, some mathematics, and some computer science. So it's a mix of all. So it also teaches you the basics of how statistics and mathematics works, but also how computers in general work. So you can go and apply those and work with your knowledge. So yeah, I think on my personal level, it was the best choice that I did, that I switched to this one, because now from the second, third, and so on, you have more optionals. Most of the degree is made up by you by selecting different things that you want to concentrate on. So that's pretty nice to have the flexibility, as you said, and to specialize on something. And
of course, especially in these international universities where people come from so many backgrounds, make sure that they have some common ground. So this is why the first year is usually, I believe, mandatory, with some wide but not so deep set of subjects, to make sure that everybody has the basics in terms of, for example, statistics, basic programming, lower level, I mean, even some lower level hardware or stuff like that. And after that, people can go into getting specialized, as opposed, for example, to more local universities, because you wouldn't expect to have so many foreign students in Romania, and then universities might assume some sort of preparation from high school, so then they might build a more, let's say, fixed curriculum of courses from the beginning up to the end.
Andrei, so I had a question for you. How are you managing a full-time role at Bolt as well as your PhD program?
Yeah. I have started as an IC at Bolt, so I was coding quite a lot, both at Bolt and for my PhD, and it was indeed quite a lot of work to do, but it was interesting, it was stimulating me, and it was a topic that I liked at both work and in my PhD. Of course, when I started my PhD, I was looking into doing something more theoretical, something about provable guarantees, about machine learning models, about their not so much about their accuracy, but more about their robustness, because there are some theoretical results about how well they can deal with distributional shifts, adversarial attacks, and so on. But eventually I realized that I wouldn't have time for that, because this sort of theoretical thinking and research requires plenty of focused work, without which you can't achieve, let's say, very good results. So you have to be there more than in one full-time role thinking about this sort of theoretical complex problems. So therefore, wanting to manage it with my role, I switched it to this more hands-on approach, where instead of working on more theoretical results. I'm focusing on practical aspects of the robustness of machine learning models, building adversarial attacks, trying to safeguard models against them. So it was for me. It was really interesting, and I had time for this. I had time for this after work in the weekends. It was manageable. Later on, I switched to the managerial role at Bolt, and since then I'm not doing so much coding at work. So then the PhD practical work gives me these nice coding breaks every now and then. So it's still keeping me into the technicalities of the role. I'm still working with pretty much the same tools, pretty much the same approaches as part of my personal PhD projects. So I think that it goes really well. It goes really well with that. But indeed, there's been an even higher load since August, because since then I'm also a father. So then I have to manage 3 full-time roles. I have to manage I'm managerial role, the PhD, and being a father. But that's an extra very fruitful load. So that's something that I really enjoy.
Congrats. You took me by surprise. I didn't know that about you. Like, you're actually a father as well. That's big. That's big. That's actually big. But probably just to give a bit more of context. I'm not sure I know it. I know it pretty well, but because I know when you're in the UK and you're doing a PhD, you're also paid, so you're expected to be doing kind of a full-time job.
Yeah.
I think in Romania isn't like that, right?
Yeah, there are some grants or bursaries you can or you can get paid for teaching a few hours and stuff. But usually I would say that most, if not all, PhD students also have full-time roles. So it's not expected that the PhD would pay enough for like a full-time role. It's rather you can obtain some grants and so on, but people in Romania very often, again, if not all of them, also have at least part-time roles or very often full-time roles.
And because I'm quite interested, having a bit of a similar background. What was your reasoning behind coming into the UK, studying at Oxford, a prestigious university? You did pretty well. We are aware of that. And then going back to Romania, where things are, let's say, not moving fast enough or not having enough resources in a couple of areas. So I know you mentioned that you want to bring your expertise and bring value, but can you maybe add up a bit about on that?
Of course. So since leaving Romania to go and study abroad, I had this dream to be able to learn again as much as I can, and then be able to come back and help to make a difference, help to contribute in some meaningful way to the Romanian industry, academia, whatever. I just wanted to be able to come back and contribute. But of course, I was mostly driven by having my family, friends, then girlfriend, now wife here. So I had many reasons why I wanted to come back to Romania. So this is sort of my long-term plan. And then going towards the end of my studies in UK, I started exploring opportunities in Romania. I found like these guys at World Quant, which were quite impressive. It was quite a nice competitive environment. And after that, I like looking more into it. I also found the Bolt and other super nice companies where you could do really interesting work. You could do research. You could do top-notch programming. So it was. I realized that Romania is not as bad as one would say. Of course, you get to live into a bubble. You get to stay around people who are working on pretty much same topics as you do. You get to, let's say, see some sort of environments that might make you biased and think that that's how Romania looks as a whole, which is not true. Of course, Romania has many issues. Romania is quite bureaucratic. Anyone like from Romania would complain about the quality of the roads, about the infrastructure in general, about trains running late, and these all are true. I think these all are true. But at the same time, I'm seeing progress being made. There's clearly plenty of progress, especially in urban areas. I think this is another part that there's a bigger and bigger discrepancy in Romania between urban and rural areas. But that's a different topic, more suitable for another podcast. But I think generally Romania is advancing. you can especially see it in the cities. You can see many big companies around. You can see the change in mentality of people in education, in the lectures that are being held at the main universities. I've seen more recently professors just taking the sort of same lecture materials or books as taught abroad. They're just looking at even at times the same slides before switching to their own slides, like picking up the same slides from, I don't know, whatever super well-known Harvard course or Stanford, and then they're just like teaching them. And these are people who know them very well. These are people who are doing research in the same topic, and they understood that these universities really succeeded in teaching them proficiently. So then they're adapting from them, initially picking up from a lower level like slides and essentially shaping their course around them. But then it just brings a change as a whole. So by sort of slowly borrowing this sort of external format of lectures or slides or whatever, slowly you're also picking up the context and the meaning behind them, and slowly people are advancing in mentality, how well they're prepared. So yeah, I think Romania is not that bad. I think, and again, I think it's progressing quite well, and there are many opportunities, especially in the IT sector.
I wanted to touch upon this subject a bit more because at Warwick there's a really big diversity. People are coming from the whole world basically, and I'm not sure exactly on the statistics, but it's I think it's almost more people that are coming from the international context rather than the UK. So I feel like the people that going to listen to the podcast will connect with these thoughts, and they'll think a bit about if they're willing to stay in the UK, if they're willing to go into another abroad country, or just go home and bring the value and all the knowledge that they've accumulated over the years, and do some meaningful work back to their countries. So that's why I wanted to dig a bit deeper into this. And another question, I'm curious. Actually, it's two sides. Will you in the future consider moving to another country from now on? And also, would you recommend people finishing their degree in the UK, regardless of their background, to come in Romania and work in our country?
That's a good question. So of course, you can never say never. You can never know what's ahead, and unfortunately, as we've seen, there can be more serious geopolitical context around which can make one or another to leave their countries even when they would not want to. And these are like more extreme situations that we've seen recently happening. But even outside that, there might be certain occasions that arise. So you could never, again, one should never say never. But generally, I'm not thinking about leaving Romania again anytime soon. Relocating with my family, I'm quite content. I'm quite content with everything that I'm able to find here. And generally for Romanians finishing their studies, for example, in UK, I think it depends quite a lot on what they want. Of course, there would be more opportunities in UK. There would be a different level of civilization. You can't argue with that. It's clearly a more advanced society, better built cities. Of course, there's quite a lot of traffic as well. There's quite a lot of traffic as well in London, but at least there's good travel in between the main cities, which is not the case in Romania. So I think it depends. It depends quite a lot on what you're seeking. I think there are good opportunities everywhere. It might be easier to find them in UK for sure. You might have a, let's say, more relaxed, safer life in UK from many aspects. But then I think Romania is very, very good as well. And if we don't think about coming back as well and contributing in some way to Romania, then
yeah. So what do you think, Via? Would you consider coming into Romania to work?
Absolutely. It sounds amazing. Andrei, so I'll ask, just taking you back to your role as a quantitative researcher, if you could tell us a little bit about how you've used big data to build strategies, trading strategies specifically. How does that work?
Of course. There's a bit background story about it. So the interviewing process at WorldQuant was super complex. It was 6 rounds of interviews focusing very deep on some computer science, machine learning, statistics topics. and I was able to go well through them just because I was like in uni days. Many were overlapping with my uni topics. I was lucky to have the same sort of lectures about martingales, risk theory, and whatever else about probabilistic algorithms. But I found them super hard, and this is like no small thing considering the exams attached for that I was also doing, the Olympiads in the past. Still, I found like the interviews, which are pretty much shaped like Olympiad problems, they were very hard. So I thought that the role is going to be extremely challenging, that it would be plenty of very complex theoretical things. There would be, let's say, very deep research to be done. But once I got there, I realized that it's actually not so much these things that still help you while in the role, but it's more about the access to big data. Once we got that access, these strategies that we would be able to build were very trivial. Like very often the most complex models that we would use would be linear models at most, or very simple approaches. We of course had some let's say simple algorithms, simple evolutionary based algorithms not built by us, that were allowing us to explore how to better combine the data to get some meaningful outputs. But then with all the huge big data that we had access to, that was costing a lot of money, of course, to get access to, with that data you could devise plenty of useful signals. And the idea with the role, as it's labeled as a quantitative researcher, you had to produce you had to produce a large quantity of such signals, such that after that some algorithms or some portfolio managers could come and aggregate all the different strategies to create something that's robust, that can work better under adverse scenarios and so on, and that produces a consistent return. So this was quite interesting. I expected the role to be extremely complex, to involve this sort of geek staying in a room at a whiteboard and just writing up theorems and proving stuff and thinking about the best models up to the middle of the night and being like very hustlers, as trader movies shows us. And in reality, it was rather building super simple strategies using big data that I thought was pretty much the fuel of the whole hedge fund I was working into. So big data, very good infrastructure behind that would allow us to ingest the data, to ingest that data properly, to use it properly in our strategies, for our strategies to run automatically, to produce signals and so on. But pretty much using some econometric, simple economics theories with some simple mathematical models, aggregating the big data and producing some strategies. That was mostly about it. And what mattered most, again, was the access to the big data, way more than any sort of deep theoretical understanding of the phenomenon, which still was required in the interview. So it was like a bit different from what I expected, but I can't say that I hated it, because essentially makes your life easier, because you wouldn't want to be like hustling like that hard continuously on a 24/7 basis.
Yeah,
Andrei,
that's sorry, go
on. When you say signals, you mean creating alpha signals, and
Yeah.
when you're okay, and when you say when you talk about the returns from the strategies that you're building, what was the time horizon that you would look at? For example, like, are you monitoring these models for a certain amount of time, going back and tuning them? What does that process look like?
Yeah, of course. So we would have some samples of data for a couple of years, and then we would produce some daily positions, which would be long, short, neutral. So we would be hedged. And then we would just produce these daily signals, feed them into a simulator, see how they would have worked like in historical data. And then we had like these concepts of in sample and out of sample. So in sample was the data that we trained the models on. We would see like how they behaved in sample, and then out of sample was some final window of half a year, 1 year that we wouldn't observe before. And then we would just see how our strategy performed after that. So what kind of Sharpe ratio we got for it, what kind of this sort of other metrics that we care about got for the out of sample one. And how it went is that we built this. This was all part of our, let's say, local prototyping, local experimentation process. Because then, of course, you could just use the whole data for in sample, or just let's say look into the future and have like super good out of sample. But that would not help you, because after that the strategy would be put out live. And then before you would get some money put on it by the portfolio managers, it would get a period in which it's just left out in the wild and simulating like to see what theoretical return it would get. And once it's consistent enough, once the results that you get look pretty much like the ones that you had in sample, it's a good signal that it's robust. Very often you would even care to have the out of sample, the real life performance, to have it as close as possible to the historical data. So you'd even prefer that to be worse if possible, but the same as historically. So if before you had some sharp ratio of, so if you have some sharp ratio of let's say 2, and after you have some sharp ratio of 5, that would be concerning in real time, because it would mean that it's not robust, it changes too much. So you'd prefer to have them very similar. So this is why very often we would look at the ratio between the out of sample and in sample to see that it's behaving robustly, it's not overfit on some period, and it would hopefully generalize. And then you deployed it, and then you deploy roughly 10, 20, 30 such strategies every month. They can be variations of the same idea, for example, capturing different scenarios. And after they ran for a while, after they simulated for a while, like on real data, and the portfolio managers would see that they're valuable, they get good results, then they would start putting quota on them. They would start putting actual money on them. So your strategies would run with real money eventually as part of some wider meta strategy.
And when you're talking about robustness in this case, how exactly can you define that? Like, do you have some metrics that?
Yeah, I think pretty much. I think pretty much what was very important was to have this real-time performance similar to what you had on historical recent data. So in terms of local evaluation, that would be that you split your data as you do with any data data science ML task. You split it in some train and test. Let's say like with a validation for now, so you split in train and test, and then you'd hope for the test performance to be sort of on par with the train one. So this is why we would call this the OS divided by IS ratio. So the out of sample divided by the in sample, and we would look at the ratio of the sharp, for example, which is an indicator used for alphas. And then if this would be at, so if you'd perform well, if you'd consistently beat the market, but this ratio would be, I don't know, 10, it would still be a question mark, like why is it behaving so much better after? Because by the same way, it could behave way worse. I mean, it's just luck that it behaves so well. You generally hope to see these sort of ratios around 0.5, 0.6, 0.7, because of course the strategy degrades. The test quality is not going to be as good as the train one, but generally we would hope to see them in some 0.5, 0.7 ranges. So this is from quite a bit of a last strategy I was building is now more older than 3 years plus. So I'm not sure what's the state of the art in terms of the approach anymore.
And because probably I was nodding, and I'm not quite sure what's an alpha signal and what's the sharp thing that you're mentioning.
Alphas are basically positions. They actually have some economic, some financial understanding, but in the hedge fund, alphas were just our daily positions. Like how do you want to position daily in terms of our portfolio? Okay. And then sharp ratio is just a fraction of your return and its standard deviation. So this means that higher values would mean that you have higher returns at smaller variations. Because you don't want to have like only high returns, but you also want to have small deviation in these returns. You want to be quite consistent in terms of them. So this again shows some robustness itself. For example, if you had like crazy returns, but at very high variance, so it would be like losing 1 million today, winning 2 million tomorrow, losing 3 million after, winning 4 million after, you'd have high return, but you'd have high variance as well. So then the sharp would decrease.
Yeah, that's quite interesting. And I'm sure there are loads of people that are into trading here as well, because it's quite of a nice finance university area, I can tell. And now, because we've mentioned this a bit earlier in the beginning, you switch out from, because it also closed, obviously, the World Count in Bucharest, but you've switched from there, a trading world, to Bolt, where you're doing crazy stuff as well, machine learning, loads of data. How would you compare the data and the roles themselves? And just one thing before going to this, what was part of this big data that you were mentioning that they were able to acquire? Like, can you talk about some metrics or there were some features that you saw in the data?
Yep. Let me start from the latter, and then
yes, sorry. Yeah.
So, it would be, so very often it would be this sort of classic fundamental data about how well companies are doing and so on. So this is not anything, let's say, very surprising or special. But then there would be plenty of other data sources, for example, sentiment analysis scores done on top of tweets about companies, fed into by some big providers. Analyst score, there are some large data sets, I think, provided, some of them by Bloomberg, but there are like many others of analysts, and they would have like some analysts who are particularly getting specialized in some industry, sub-industries, companies, and then they would provide their price targets for some horizon. And then you have these large data sets, and you can think of it as a matrix where you have like many analysts on one axis, and on the other you have like the companies, and this is like for a day, this is the price target that they set for tomorrow, for example. And then this would turn into a cube or like tensor. If you start moving along the temporal axis, you'd have their price targets along a week or so, along a week or a month or whatever. And then you have to aggregate them in some smart way to create something accurate. And here you can think about tracking their historical performance, if they were good, placing more weight on their prediction for a certain stock and so on. But yeah, of course, we had generally some. We even had some strategies created by some analyst companies, so they would create their own strategies, and we would use them as meta strategies, meta inputs to our models. But yeah, very often it would be this sort of plenty of analyst data, plenty of predictions for different indicators of the company, and then using some economic theories about how the price would look like given, I don't know, their growth in earnings per share or any other sort of indicators. So we would use these predictions for different indicators to predict how the stock is going to move, or even use the price target that I was referring to directly into our strategies. So I would say plenty of analyst data, but fundamental data, but also this sort of more special data like tweets, sentiments from tweets, or even maybe like for some companies even weather data. If we saw that there's like some good scenario where it would impact, you can think about. I'm making up, but you can think about fleets of ships that wouldn't be able to navigate well during certain storms and so on, and you could expect stocks of such a company to fall. You could think about more extreme scenarios where I've heard about this. This was some story that actually got my interest about the sector. That you would have some daily satellite imagery from ports, from naval ports, and but yeah, I've heard this was like one story that really got me into the topic, but I never got to work with such cool data. And then you'd be able to see the projection of the cargo ships on the water and assess how large the shadow is, and use it as a sort of input to understand how well some businesses are doing. But that's quite extreme. It got me like really interested, but I can't say that I worked with such cool data. Usually the data we're working with was tabular, big data, and costed a lot. Like access to it was quite expensive.
Because probably other people had to do their job and to analyze it and make it in this format. Because it's quite interesting because you mentioned some of these things. We actually had some speakers from Bloomberg and Econometrics, and they both talked on how they take data and analyze it and make it in such a way to then ship it to other companies to be used in other various formats or consult companies and things like that. So it's quite nice to see how people are interacting in different ways and how pieces of puzzles are putting together. So yeah, that's quite interesting from my perspective at least, because I'm seeing these talks and discussions. And now coming back to the switch between the companies, the roles, and how the data is represented.
The data that we're working with at Bolt is proprietary data. Most of it is proprietary data, and then we're getting to work with the data of the rights of our clients, orders of our clients, statistics that big data and statistics that we own internally. So this is more interesting because we are essentially the producers of the processes that generate the data that further fuels up our new processes that we're building and models and so on. So from this point of view, it's very interesting. And I would say that generally what I enjoy most about Bolt is that it's a product-driven company. It's a product. We have many products, and it's I believe, at least personally, it's so much nicer to work on proper products, see them evolving week by week, month by month, and know that you're contributing to something meaningful, actually meaningful, and to see impact you're actually making in the lives of others. That's way more fulfilling than creating, I would say, cold alphas, because they were like interesting. It was like working with very, very smart people, but they felt quite cold in the end. It was not really what I was expecting it would feel like. But working with a product is really interesting, and I think I would most likely never want to trade back to some non-product driven company. Again, with never say never caveat, but I would just enjoy working on product driven companies, building something that you can quantify, measure, and essentially be proud with.
I think this comes down to what drives you on a personal level, because maybe some people are really into seeing numbers growing, crazy, making crazy money, and building loads and loads of fortune. But yeah, for your perspective and mine as well, I love to see the actual impact. I know that I should aim for midterm and long-term impact, and to see it how it evolves in a longer period. But sometimes it's quite fulfilling when you see it on the spot, or maybe in just a couple of hours a day, how what you did actually impacted something in the works of the others. And probably for your case, there will be a lot of people that would thank you for the drive that arrived in time and got them to maybe some exams or some dates for some important events. And I'm curious how if you ever if you ever take a step back and realize, oh, okay, I'm working with this data, I'm working on a product, I'm impacting a lot, I'm making lives better. But if you ever think about an actual situation where somebody used bolts to get somewhere, and maybe that you had a way of managing this.
Of course. So I wouldn't give the example of all the angry rants I get from the drivers that are taking me from some locations to another, telling me about these guys at Bolt who are always messing with case, and if only he'd get his hands on them. And then, of course, I'm not telling them that I'm working at Bolt, but more actually, the example I'd bring up was it was back in 2020. It was the first summer after I started working at Bolt. And back then, I was building the first large-scale ETA model in the data science infrastructure before we've had some sort of prototype deployed in the classical backend stack. But nobody was maintaining it. It was not really tuned, retrained anymore. So I had to build it in the data science infrastructure and then start deploying it on different markets. And this was my onboarding task actually. And after 2 months, I was running this new model on the new infra in Bucharest and Tallinn, which are our, let's say, main debugging markets, because we've got development hubs in both Tallinn and Bucharest since then. And since then we've grown quite a bit, but back then it was mostly Bucharest and Tallinn. And we first deploy stuff there to see if it breaks something in reality, because it's easier to assess like from the ground, apart from statistics and all that.
Yeah.
So I was deploying these models. We ran some tests. We saw that everything was fine. Accuracy was good. We rolled them out, and then it was one night when I was traveling with Bolt after arriving in Bucharest from my hometown Ploiești, which is near Bucharest. I took a Bolt back to my place in Bucharest, and I was seeing all of these Bolt branded cars around. And I was thinking that they're all driving using my ETAs, and they've been dispatched using the ETAs that my algorithm produced. And I had this sense of tremendous realization, tremendous, let's say, job fulfillment. I was literally happy. Like I look at all the Bolt stuff moving around, and I knew that some input that it gets is from my ETAs, and drivers are dispatching according to it. Drivers are thankful or getting angry thanks to it. Still, I'm making a difference. So it was very fulfilling.
Because I know we've been talking about these nice scenarios, and you also said that some drivers are complaining, obviously, but I want to hint you a bit with how do you feel Uber is threatening what Bolt is doing, and like how do you usually perceive uh, a company that's in the same sector? It's quite an opponent because you're in a way competing for the same people, in kind of I don't think they're in the same markets, but roughly in Europe, let's say, the same cities. Uh, like how do you perceive, and do you feel like they're a threat? Do you like that they're doing that thing? I know Bolt is an European company, Uber is an US based one, so there's some difference in there as well. But yeah.
We at Bolt label ourselves as honey badgers, if you know the animal, like the small cute thing, and that's mostly to their amazing skills to survive around the serious threats, to fight clients and so on. So it's sort of like the small player that manages to stay on their feet, keep their ground, and survive and even thrill. So this is how we also felt about these competitors that are indeed very big. They've been first in the game. They've got good historical reasons to be first in the game, and generally their services have been evolving since then. Of course, they've got longer time they've put into developing their product. But what we've done very well is that I think we've always excelled in terms of operations, and we also stayed frugal and we sought the most fruitful opportunities. This is why I would say that maybe with a small part of all the people that big competitors might have, with a very small part of it, we were able to build similar products. And for example, I've been having an interview with somebody working at a similar big food delivery company, and they would be working on the mapping part of that company. And they would ask what we do at Bolt in terms of mapping, and I told them about our usual ETA work, working on improving ETAs, working on keeping the maps quality high, working on ranking the search addresses in a relevant way to the clients that are looking after them, and a few others. And then in the end, he would say, yeah, we do pretty much the same, and we're a team of 20 something. And I told him, yeah, we're a team of 3 or 4 people. So he was like amazed, and I explained that it's not like we are hustling, we're overworking to amount for the same work, but rather we work on this sort of very classic principle that we very often do the 20% of the work that gets you 80% of the impact. We exploit many such areas, and after we've exploited these areas, we see which is the most impactful, which is the thing that really makes sense to pursue further, and then we insist on it and on making it more efficient, more optimal. So this is why we managed to win many markets. This is why we placed ourselves as one of the top players in Europe and Africa, even against these very big players. So of course it's not an easy job to start like in a market that's already occupied, but we managed to do it by this, let's say, frugality and efficiency principles. And now we're in a good state across again both Europe and Africa. And generally, I think competition is healthy, because if you have like no competition, you would just plateau out. Why would you even improve anymore if there was no competition? And I felt this personally as well. Like I always liked having these let's say adversary friends, because they were friends of mine that we were fighting off to get the best, I don't know, grades in uni or to achieve top places in Olympiads and so on. It's very useful essentially, because otherwise you wouldn't be progressing.
And what do you think is, as you said, the market was a bit developed and Bolt came a bit later. And I would say it's still a young company. And you're talking about how other competitors, and probably they were like, and others, like Uber and stuff. But do you think that I'm trying to understand if you think it's because they've been there for a longer time, that they have to do those incremental adjustments and improvements because they already have a fully developed product, they already know that they're doing and stuff, and they just want to, I don't know, appeal their client base or their investors and stuff like that, or is it more of a other thing that you reckon is having those two different approaches?
Yeah, I think very often it's important to find the right balance between exploration and exploitation, which is a classic reinforcement learning paradigm.
Yeah, sure.
You have to understand first which are the avenues that you could explore to enhance your business. And that itself requires some work, because you can't say, for example, if making ETAs more accurate would help your business or not. Of course, it's nicer to have more accurate ETAs, but then does it really matter whether you predicted 2 minutes and 59 seconds or 2 minutes and 10 seconds or 2 minutes and 30 seconds? I mean, maybe you'd still be, your ETA would still be 2-3 minutes, or if it's 3.5 minutes, and this gap is only like within 1 minute, it wouldn't really matter that much. So you'd think what is the right time to stop improving ETAs that doesn't make any more business impact, and that's unnoticeable from a UX perspective. Because then from the other point of view, investing into such research can be quite expensive. It can require quite a few people focusing on this topic for quite a while there might be more sensible opportunities elsewhere to explore. So it's not an easy job to understand how to balance exploration and exploitation. But I think very often this is where we excel at Bolt. We would know when certain avenues don't make sense. We're not still that big of a company that would move out of inertia towards some unimpactful topics. You can imagine in a company of tens of thousands of people, you can imagine how hard it would be to stop some strategic direction where tens of people are working towards, and still there's like they're doing their job well from a technical point of view. There is no business impact from it. It's hard to measure, it's uncertain, but they've been working on it for years. It would be very hard to stop that, to just stop that. What would you do with those people? Would you start relocating them? Would you do layoffs? What is there to be done to stop this sort of mammoths moving towards a direction that is not the right one?
Which is quite happening. Yeah.
It is for sure, and I would say that especially with non-technical companies, it's very hard to, if not non-technical, but rather not data-driven companies. You would have, especially when you have these not data-driven decision factors, people would think that doing something or doing the other is better for the company without clear evidence, and then they would insist on certain avenues that are not impactful, and then it would just be many people on your payroll working on unimpactful stuff, which is basically just a money sink. At Bolt, I think we managed to stay very well out of that, and we are balancing data-driven decision with being sensible, because of course, you can exaggerate with data-driven at some point and just experiment anything that really makes sense, spend a lot of, let's say, data investigation, do a lot of data investigation on it, and essentially be left with the same conclusion, or even a different wrong one, because data might be misleading at points. But I think we balance very well data-driven with being sensible, and then we know when to early drop certain initiatives. So if something doesn't seem to work, we just drop it early and then move our working force to something that makes more sense. So for example, we, from a business point of view, we know about what we care in each of our sub teams. So like in the maps domain, we still know that we can improve a lot our business efficiency by making more accurate ETAs. We've shown it experimentally. We know that we can improve our search experience to make people not drop due to frustration of not finding their destination and switch to competitors. So we know a few certain areas where we can make a difference in terms of impact with data science, and then we're insisting there. We're making ETAs more accurate, then retesting whether indeed we get a better marketplace due to more efficient allocation of drivers. We see that it's indeed the case. It brings us extra money. It brings us extra GMV. Same for the search sessions that we make people convert to. If we rank better the destinations we show them, we can measure that conversion increased. So very often all the projects we're working on have some clear business goal in mind, and we're sticking to it. We're improving this, and we're not going very often into these efforts that we estimate would take many quarters and have some unclear impact, but just some product manager would think that they might help, for example, in the future. We usually don't do those. We keep a very critical eye on, and even us as data scientists or engineers, even we have, let's say, this mentality education of pushing back any such potential projects ourselves. Well, we're not the owners, we're not product managers, we're very much the owners of the work we're doing, and we want it to be meaningful. So I think it's a thing that it's not a top-down thing. It's rather, let's say, fully connected graph where everybody tries to enforce others to work on meaningful stuff and to give them meaningful projects. And this way we sort of keep each other sensible and working on what actually matters.
That's quite impressive. And what I would take from this is I want to better understand, how do you find it different for you now that you switch from coding those models, implementing those ETAs, doing some. I know you've told me in different conversation that sometimes they're really basic mathematical and statistical model that they're using, and they're quite efficient and have some good accuracy compared to some fancy other new technologies that are not sometimes not getting some of those big numbers that you expect. How do you find going from that doing the work yourself to having now to manage three teams, because you said you have teams that you're managing, data scientists.
Yeah.
How do they compare? Like, would you?
Yeah,
I don't know. Yeah.
It's certainly a big change in scope. You slowly give away all the coding aspects of your job. You slowly move into the more people management side. But I would say that what's most fruitful that you can really achieve as a manager and that you can observe is something that I've learned in my term from my manager, that you make sure that your teams your teams work on stuff that matters. Because again, very often it might be the case that the project that your team would work on, you or your team think that they might not bear the right business impact, or you think that there might be some better things to do on the table. Of course, most often the product teams that we're working with, the business divisions, they know like what they need, but very often I think that we've got very good data understandings and we know what's there on the table to be done with our tooling. And then you have to do a lot of this work to make sure that your teams are working on stuff that actually matters. And then, of course, making sure that they're working efficiently, that they're maintaining a good team spirit, that they're happy working on that, they're having their personal growth. So this all comes along. This all comes almost at once, as long as you're sure that your team is working on meaningful stuff. Because working on meaningful stuff means business prospering, but also people seeing that their work makes a difference, which contributes to their mental well-being. They're motivated to do it. They're happy with the outcomes, as opposed to working on stuff that doesn't matter, when you know that you've technically done your part, but you're not seeing the results, which is not motivational. So indeed, as an IC, as a data scientist or engineer, you wouldn't have to do this at a team level. Very often you'd still, at least at senior plus level, it's expected to try to work on meaningful stuff, try to push people to pursue the impactful directions, impactful projects, but not at the group level. As a manager, you have to carry much more of this. You have to make sure that people are working on what they should from a business point of view, that it is the best thing for the business, and in turn the best thing for them, because they're growing. So but it's of course like very different work in nature, and you're getting a way more high level view than before. You get to understand more topics, you get to understand the dynamics of how our marketplace are behaving, but it's not anymore hands-on work. Personally, I still keep like this hands-on work through different approaches, as I was saying, like through my PhD, or more recently participating to some traffic forecasting competitions. So I'm still doing, at least in personal time, some hands-on code. But yeah, the work is generally way more higher level, and it's useful. Like at this stage, I'm looking at the dynamics of the food delivery marketplace, which I know about from my team working on delivery, which has its own manager reporting to me. Same about the rentals domain with scooters. And I'm seeing many parallels. I'm seeing many things that can be borrowed from one to the other, many potential collaborations across these two domains. Same in the maps domain. The maps domain is working agnostically to the vertical. So they're creating maps for all our businesses, for ride hailing, for rentals and delivery. But still, we're measuring its business impact it's having across all of these. We're producing ETAs for everyone, and we want to see like how it impacts these marketplaces that I mentioned. So then you can imagine there's plenty of synergy between the ETAs we're producing, how the delivery team is consuming them to allocate couriers and so on. So it's clearly very fruitful from this point of view, because you get to see many deep projects from different areas from a higher level, and you can identify the synergies, the common stuff in between them. as opposed to my work before, I was scratching the surface of all of these topics. This is how we reached this group, but I didn't get to go too deep into them because of balancing multiple topics. I was rather doing that 20% of the work to ship 80% of the stuff. Now people are going a bit deeper into the ones that make sense from a business point of view, and I'm sort of there to help them find the right opportunities to explore and exploit.
Yeah, no, that makes sense. But I'm just wondering, when is it too far to take data-driven decisions? Do you do that with your teams as well, when like maybe how they're performing or how the dynamics between them are? Like, I'm curious if there's some data-based way to analyze how the teams are doing, not only on maybe on the earning side or things like that.
Yeah, of course. Yeah, I think once you get into that, it can easily become quite toxic, as we've seen with Elon Musk and Twitter counting the lines of codes, the PRs and whatever else. So totally, to be honest, I never even really cared who committed how many lines of code until I realized that at a point I was doing when I started at Bolt, I was doing quite small commits, and I realized I was getting like in top 3 or top 4 of the commits in the data science group with some of the fewest lines of code, just because I was committing at let's say too often granularity. So then I understood that maybe my commits were not at the right granularity. There can be like stuff like this which would be helpful. But even those, essentially, they don't matter. Like I, as a manager, I don't look at how many PRs, how many lines of code, how many whatever my team is doing. There are just these small things which don't have to be assured through statistics. I want to know that people are collaborating well, that they're seeking advice, that their solutions are getting, as it would be like in academia, peer reviewed. So not only from a code point of view, going through PRs and addressing comments and finding whatever bad practice in terms of coding inefficiencies, but rather that the whole method is reviewed somehow. Usually I also take part in that, but it's also what I want to see in my teams is them doing these peer reviews in between themselves, keeping themselves with the feet on the ground, making sure that their methods are valid, that their methodologies are solid. And this can't be assured through any sort of statistics. It's just working practices that people get used to, and my teams have got used to. And this is what assures you proper good results. And I can say some of the most impactful stuff that we were doing, in fact, had very few lines of code, like the first ETA models, both for ride hailing and drive and delivery. They were super simple models. If you look at them, it was mostly boilerplate code for like the serving layers and so on. And I don't know, 100-200 lines of code, or super simple models that, of course, you spend some significant research behind finding the right models, right methodology, right data. But then the model itself was super simple usually. Of course, since then, as we realized that it's quite impactful, we insisted more. We built it according to more proper software engineering approaches. It's now big models, big pipelines, many lines of code. But in the past, we cared mostly about the impact, and now we still care about the impact. But now we've switched more to looking at the quality of our code and solutions from a software engineering point of view, because unlike in the past, now we're fulfilling hundreds of thousands of requests per minute or even more. So we have to be very robust from this point of view.
No, that makes sense. And I know you mentioned a bit, you're saying that teams are building maps. What would that actually mean? Is it actually meaning building those maps in the app, or what?
So Bolt uses OpenStreetMaps, OSM. These are some open maps that community contributes to, and it's basically an open source layer of maps where you've got ways, which can be streets, for example. You've got relations between them. You've got nodes. It's pretty much a graph with properties. And we are using those maps, and for running routing, for example, from a point A to another point B, we're using again some open source routing modules, which are just generating routes using Dijkstra. But this is only the infrastructure, because after that we have to contribute to this mapping stack with quite a few things. For example, we're building traffic estimates per each street segment at each time of the day. We want to forecast how the traffic is going to look like. This is information that we built using our internal data. We want to understand how long travel is going to take from a point A to a point B, whether it's, for example, for picking up a client or for dropping off a client to their destination, or for picking up fruit from the restaurant, or for taking food from the restaurant to the client. There are many scenarios, many combinations that we want to estimate ETAs for. And these depend quite a lot on the use case. Because, for example, if you just want to drop a client at a certain point in a high traffic intersection, the driver might just stop by, the client would jump out of the car, and then the driver would proceed, getting a few honks from the other drivers, as they would in Bucharest. But in food delivery, if it was like around the same area, they would have to find a place to park their car. So that's longer ETA. They have to maybe sometimes circle the building to find the right parking spot and so on. So it gets way more intricate. So we have to build models for all of this. We have to improve ETAs, to improve the mapping of these pins, to propose where people can leave their food, where people can get picked up. So we have to do all of this. We have to maintain the quality of our search experience. Again, we're using these addresses available on OSM, OpenStreetMaps. It also comes with some addresses, of course, like with the streets, but also with some points of interest, POIs, like restaurants. But then we're also adding other data sources that we can access, open sources, proprietary sources, and we're even maintaining our own sets of POIs and of additional changes on top of the map that we are detecting using our in-house data. So, for example, we're using GPS tracks of our drivers to detect if OSM, these OpenStreetMaps, have some missing streets, and if we find these missing streets, we contribute them back to the community. If we find some one-ways, for example, missing one-ways, we contribute them back to the community. Same about turning restrictions, traffic lights. We find all of these elements using algorithms to keep up the map quality and contribute them back to the open source, to give back to the community. And then we also have like this list of internal whatever addresses that POIs that people might look for, which we don't contribute because they might be stuff that's very concrete to our business. You can imagine I don't know, nicknames people give to Bolt, and pickup spot or stuff like that, which wouldn't make sense from a public point of view. So we also have these. And we're detecting all of these with many algorithms. We have like many detection algorithms, both supervised and unsupervised. We have proper ETLs, pipelines to extract, process this data, and create suggestions. And in the end, we have a team of map specialists reviewing this manually, especially for the ones that we add in the upstream, so like back to the community, because additions done to the community have to be done manually and validated by somebody, because you don't want to mess with maps that many people use from the open community. So then these map specialists, they would look at our proposals, like we think that there's like a road missing here at these coordinates. And then they would use, for example, street imagery from drones that maybe we used to gather images or that we got from a third party. They would see that indeed there was like a missing street. They would then add it back to OSM, and it would be reflected in the next map update.
And what's the reasoning? Sorry, you've been talking a lot, but what's the reasoning behind using those OpenStreet sources rather than maybe some Google Maps or Apple Maps or whatever?
That's a very good question, and there are two reasons. First of all, it's for free, so the OpenStreet are for free, but so Google APIs, whatever else APIs, they cost a lot, and we've historically been using them, but they've been a massive cash burner for us. We were sticking building our internal solutions. There are these OpenStreetMaps available, which are not of similar quality indeed. But then this is why we've been building our stuff on top of them, contributing our predictions, building our models. And then the second reason is that Google, for example, Google would provide you ETAs from a point A to a point B, but these wouldn't be fit for our specific business cases. So they would provide agnostic ETAs for traveling from A to B, no matter like what you want to do with that, because that's what you matter when using Google Maps. That's what matters when using Google Maps. We, on the other hand, we care about the scenarios that I described before. Driver, courier. So we would still have to learn all of these things, do our own adjustments. And then if you're doing all of that, why not have your own internal mapping and not pay for it? And what we've observed is that in the end, when we're drawing a line at the end of a ride, we are on average more accurate than what Google was providing us in most of the markets where we operate. So we've got a solution which is way cheaper, works better than Google's. For us, it's best of both worlds, really.
And my final touch from my side. I'm not sure if you wants to add anything else, but I was reading in various sources that sometimes, because as you said, maybe you don't really have the expertise or the team to build your own maps, so you can't really do it because you can't afford it in matters of expertise and time, but you have the finances and you have no other choice but get the solutions from somebody else. But what do you think is the best balance, and how do you usually approach
Yeah.
what things would need to be built in-house to maybe reduce costs, be less dependent on third parties, make sure that everything runs smoothly? For example, probably the best example that most of the people are aware, the Apple chips, because they work brilliantly in their ecosystem, like their M1 and 2s. They are
Yeah.
working quite well with their MacBooks and their tablets and so on. Now Google also copied that. They do their I think they're called Tensors or something in their Android phones, in their Google Pixel phones. Um, so where do you think these two approaches make sense, and when and how it's best to take one of them?
Yeah, build versus buy is indeed, it's an excellent question. It's very, very important to be able to tell when it's the right moment for either of them. And for example, how I think about it in a general way: first you think about which would be, so of course you're looking at the cost of each, because each bears some cost, both build and buy.
Yeah.
In both, let's say, you can estimate this in both cash, so you can see like how much you pay for the development of one, how much you pay for the integrations that you have to do with another end, for the API calls, for example, if you're calling some external solution. Also the time frames, how long it would take to get to that state. Maybe it's like business critical to have something running very soon, and then you can't afford spending too much into building something, so you're just pressed to ship something that, I don't know, does some regulatory thing which you wouldn't be able to operate without, and then it's just like a matter of buying a solution. But generally it's about balancing costs with benefits. You have to think about what is there for you to gain if you are to build something. Does it really make sense? Could you build better than it's already outside there? And would it make sense from a cost point of view? Very often this can be estimated with the so-called Fermi estimates. Like you can put on a paper and estimate what would be the cost you'd get from each, the returns you'd get from each, and just make like a calculation like this. But what happens very often is that there's like plenty of uncertainty about what you really need and whether it would help. So very often when, for example, let's go back to ETAs. For example, when Bolt started, there was plenty of other things to build. ETAs were just like a component in the whole ecosystem that was being built. So there was clearly more importance in building the actual systems of dispatching cars, of the application working, and so on. And building a whole ETA stack on top of maps that we didn't have like either, apart from the open ones, that would have been a very, very time consuming thing, which would have maybe cut our competitive edge that we could still get against competition, and then we would have been out of the game if we didn't focus like on the right things. As opposed to that, first approach was to go with a buy approach. For a long time we've been using Google mapping APIs. We didn't build much stuff around it. And after we've seen that there is indeed value in it, that more accurate ETAs mean better dispatching of our drivers, better UX, clients appreciate it. We've got robust services. The application wasn't crashing so much. We had good dispatching and so on. Then we took like a step back and said, okay, now we're paying that much for those API calls. We're in a secure state where we've got like a good market share. The application is working well. Let's now go and build that thing that we're paying a lot for, and which we would be paying like even more for with the current growth. So I think it's also a matter of opportunity at the right time. So very often you'd like to first buy something and then gradually build it. It depends quite a lot on the situation and on its specifics.
Andrei, I had two quick questions if you have the time.
Of course.
So my first one was to understand from your perspective, have you ever encountered a conflict of interest? Or for example, there's been a situation where there's a technique that needs to be adopted or that's been recommended, but say, for example, the stakeholder is not comfortable with the approach, or at the time of evaluating, you realize that maybe the best fit model could have been something else. So just understanding how do you deal with disagreements, especially in a field like data science where there can be so many different perspectives for the same problem. And my second question was if you could quickly talk about, your PhD thesis, what is it about? And yeah, that's all I have.
Of course. Yes, so about the first question, it's often the case that you and the product teams that you're working with, sort of business stakeholders that you're working with, they would have like different opinions on what's there to be solved with the data science tools that you have. One thing that I have always been pushing against was being told which solution to use. So I would say that once it boils down to solutions, I would just ask people to take a step back and just think about the high level problem that we want to solve. Because of course there might be people who have some expertise in the field, people who understand the field, but still is the best like for this sort of communication between data people and business to talk about things from a problem point of view, like what is the problem that we want to solve first of all, and not what is the solution to it. So I think that already cuts a lot of friction, because once you realize that you have to first nail down the problem, understand what's there to be solved, then the matter of finding solutions of course can be like a collaborative thing, but it's way more technical and has to most often be driven by data science. And then I think that cuts already like a lot of friction once people understand that. But of course I've had like situations where people would not be confident that certain data science approaches might help. And then you have to push it. You have to show impact. You have to build quick prototypes to show that there's like some impact up to it. You have to bring up historical data to show that certain improvements that you did in certain fields were helping the business a lot, and that you could replicate them along new similar fields. So I think that it's very, very important to and this is a mentality that we promote each other, that we are challenging each other but meaning well. So it's natural to challenge others' beliefs, but once we all realize that we all just want to get impactful stuff working, we just want to make the business prospering, then it's just a matter of bringing arguments, seeing data-driven evidence, seeing our sensibility out there, and just seeing what makes more sense. And in the end, everything can settle if people are willing to do the best for the business, and if there are sensible people, it just gets solved out. Generally, I like to tell my teams this sort of view that I have, that we can assume that you should assume that everybody around you is sensible, and that if you reach very different perspectives on something, it's two things. You either had access to different ground truths, so like the laying foundations of the argument that you're making are different, because if you start from different sets of premises than others, then you'd get different outcomes. So it's one of these, and then you can go like to ground zero and see if you have access to the same ground truths, or there is some difference along the way of reasoning, and then you can identify which is that, like, let's say, relation between which is that step of the reasoning which differs, and then just tackle that directly. Because I might think that, I know that more accurate ETAs help the marketplace. Somebody might think that more accurate ETAs don't help the marketplace. By that I assume better matching drivers to clients. And then we have to think along the way, like, okay, ETAs, they're used in dispatching allocates drivers to clients like that, they're using ETAs as input, and then we believe that it would mean that more accurate ETAs would bring pickup times down on average. So this is like the step where we disagree, that more accurate ETAs would bring the pickup step to a lower value, the pickup time. And then we start discussing about it, we start looking at historical evidence, if there's some data driven to it, if there's some experiment you can run. So very often, if you nail down what's there that creates the sort of friction, you can just tackle it. And in terms of my PhD thesis, as I was saying in the beginning of the podcast, I started with these more theoretical approaches. I realized I didn't have time for them, so now I've been working on way more practical aspects of robustness of machine learning models and adversarial attacks. So I'm exploiting simple black box adversarial attacks. These are the algorithms that fool machine learning models to believe that some samples that are obviously to a human of some class, for example, an image which is of a dog, very obviously to you, would fool a machine that initially classified it to be a dog, but after modifying 2 or 3 pixels, it would think that it's a cat or a cake or whatever else that doesn't make any sense. And this is what's labeled in the industry as illusions for machines, because it's pretty much the same with humans. When you see like some shapes that seem 3D or that seem something else from different perspectives, it's pretty much argued to be the same for computers. These sorts of like minimal changes that change their understanding to them, but which don't to us, like changing a few pixels. And it's quite an interesting problem, and I'm dealing with it mostly from this black box point of view, which means that you don't have access to the model doing the classification. So you can just call that model. You have like some sort of prediction API. You can call it on certain inputs, and then you have to run some search on the input space to see what changes can you minimally do to fool the model. And it has implications in the safety of AI, because if you can exploit such simple models, such simple patterns of attack, it means that any attacker could do so against, for example, self-driving systems is the classic example, but it can happen like in many other circumstances where you'd fool automatic AI systems by minimal changes. And there have even been some really cool literature entries, but this go already back quite a few years, more than 5, I think. Time has passed a lot since then, but there were these examples with people printing 3D glasses, like green glasses on top of cardboard, folding them over, and then just drawing certain small pixels on top of their frame. And those pixels would fool classifiers that they're Pamela Anderson or Angelina Jolie or whoever. So just by those like small, and they would transfer. So like you could move around the frame, you could take pictures in different lighting environments, and most often you could consistently fool a classifier that you're a certain other person. And they did, I think in the literature, it was done the same with traffic signs. So they would stick very small patches on top of stop signs, and they would be transformed into some, I don't know, minimum 30 kilometers per hour speeds or whatever. So it has wide implications, and if you know better your adversary, you can better guard against them.
That's quite interesting. I'm really not aware of these works. Like you opened a new whole area for me, to be honest. And what libraries can you use for these, like those black boxes? Like do you use certain like most known libraries or what?
I can tell you that the approach is the first approach that I tried was just generating random bounding noise on top of the image and just retrying that until you fool the classifier, which is the simplest thing to do. And that already, with some decent bounds of perturbation and some decent waiting times, like a couple of seconds, a minute at most, for example, it would be able to fool models working on classic ImageNet or sci-fi data sets in more than 60–70% of the cases. So even something simple like that can work very well. But after that, what I've started doing was implementing simple evolutionary algorithms, just moving from samples that you have found to decrease the probability of something being classified correctly, just moving from those further, generating random perturbations, picking the one that works well. So for this, you can imagine that you don't need like too deep intensive libraries, because you're just implementing simple evolutionary based strategies. But yes, I've also been using some out of the box libraries, which are generally used for tuning models. This is called, one of them is called Optuna. This is basically taking models as inputs and hyperparameter ranges, and this generating on top of some data set is generating the hyperparameters which achieve the best, for example, validation loss. But I've been able to very simply reuse this sort of tool, which is just a generic optimizer. It's a black box optimizer optimizing black box functions. It doesn't care about what functions look like. So then it was very suited for my use case, because instead of fitting some model with some hyperparameters, I'm just feeding in black box models,
The black box,
and it's exploiting how to perturb the image. But these are like some other experiments I've been doing. I've been using some explainability tools as well to understand my attacks better, like Shep or Lime, or there are a few libraries nowadays which are very useful for this explainable AI side of the things. And while I'm generating attacks, either by classic algorithms or by using some optimization libraries, at the end I'd be interested to see how to interpret those, what actually happened, and then you'd use some explainability modules like this, like Shep or Lime.
And can you, after you've done all this process, can you take any, like, can you suggest any improvements to the model in order to not be full? Because you're saying that you need to defend yourself from this.
Yep. Very often, you can. So if you know very well your attacker, if you know what attack they're going to do, you can of course build tools to detect it, and this can range from super simple safeguards to even models that detect them. So you can feed like both perturbed and unperturbed images and just train models to detect them. But if you know very well your attacker, this can be simple deterministic rules. You can expect some variations in some frequencies of the image, or of course, if you change like the value of couple pixels randomly over the image, there would be some sort of discontinuities in the color scheme of the whole image.
Oh,
so
right.
you can identify this. But usually some attacks don't even show that, like they're doing the changes with some gradients and you can't even notice them anymore. So what's the sort of generic approach to it is adversarial training. So you're having a model, taking images, adversarially perturbing them, then retraining the model on top of both the unperturbed and the perturbed ones. And what happens usually is that your overall accuracy on the unperturbed data set would decrease a bit, because you won't be able to have like the same capacity for it, but it would be way more defended against that particular type of attack. Still, it doesn't say anything about how well it would defend against arbitrary other attacks.
That's quite interesting, but I feel like we need to wrap it up here. We've been discussing for quite a lot. Probably you'll have a big glass of water afterwards and take a break from. I don't know if you're living with your wife and kids now, but probably hopefully you'll have some more energy to talk with them as well afterwards, because it's been a long episode. But yeah, I feel like at least I've been learning a lot from you, and I'm looking forward to maybe join an internship as well. I know I've run that a couple of weeks before. But yeah, looking forward for other interactions, maybe having an in-person meeting. Thanks a lot for coming to the podcast. It's been quite a nice story to hear, and some nice insights to get from you, Andre, and we're quite excited about that. So yeah, thanks a lot again. Have a nice day.
Thanks a lot. It was great. It was really great. Thanks for taking the time, and I also really enjoyed meeting you and this podcast. And looking forward to the next opportunity to meet in person, virtually. And of course, please do apply to Bolt. I'll let you know once what are like the suitable openings we have. And I just encourage anyone to look at our careers page. We have many interesting openings still in many different domains. So just take a look or reach out to me.